of 2/3 of a meter. The global proliferation of real-time centimeter accuracy positioning devices, such as cell phones. Some of the new cell phones have already monitoring the new frequencies, L2C and L5 from the GPS satellites. And this is going to change before the end of 2022. And it will be an immediate change, not a gradual change. Possible impacts. Every historic position on a map, chart, survey, etc., with an assumed accuracy of 1 meter or better will become obsolete. Transformations will exist. Some of the tools are already online at NGS to help with this information. All existing navigating and mapping software will become obsolete. Again, 1 meter or better accuracy. If that matters, then it's obsolete. NGS is already working with the industry to get ahead of this. That includes, ESRI for ArcGIS, AutoCAD, Bentley MicroStation, other stakeholders in the industry. Will there be conversion tables? No. This is pretty much going to be a digital switchover, and we won't have the old-fashioned pull a book out and figure it out. Will WGS-84 be updated as well? Not necessarily. WGS-84 is a military system, and the military is not beholden to the civilian spatial reference system. But NGS is working with the National Geospatial Intelligence Agency about the new system and how it could affect WGS-84. Just a reminder that it's not part of the National Spatial Reference System because it's a military-controlled system. One thing to know, raw data coming from GPS satellite in your handheld, or if you turn your phone on and you see latitude and longitude coordinates, those coordinates are in WGS-84. Right now, it doesn't really matter because the difference between 84 and NAD-83 is about 2 meters or so between the two, and that'll be fixed very soon. Currently, all civilian federal agencies are required to work in a National Spatial Reference System per OMB A-16. But again, this is NAD-83 and all its iterations, and in vertical datum, NAVD-88. Just a note again, UTM is not necessarily defined as WGS-84. WGS-84 is a datum, NAD-83 is a datum, WTM is a projection. So a projection, you get a northern and eastern set of coordinates, and with a datum, you're getting a latitude and longitude. However, that being said, any survey quality work being performed in North America, in my opinion, has a 99.999% chance of it being WTM NAD-83, not WGS-84. And the reason why I say that is because all the course data, course stations, the GPS control in the United States is monitored or run by NGS or some of the states, but they're on the same system. They're all on NAD-83. And you can get coordinates in UTM, but they will be based on NAD-83, not WGS-84. So again, replacing NAD-83 will impact the Department of Defense if you receive any survey quality data for any project in North America. The rest of the world, I really don't know how that would affect. It should not, but I don't know. So we're going to replace NAD-83s and all those iterations, and we're going to end up with the North American Terrestrial Reference Frame of 2022, the NATRF 2022. They're going to have one also for the Caribbean. They're going to combine these two. The Pacific will have its own for Hawaii and some of those areas, and Guam and the Mariana Islands will have their own system. But all be referenced to 2022. We're also going to be replacing NAVD 88. And here are the other equivalents to NAVD 88 for Puerto Rico, the Virgin Islands, Guam. So those will all get replaced. One interesting note is, if you see here, we're going with a geopotential surface. So it's going to be a unique, what we have now is something that's kind of a hodgepodge of everything, and we're going to go to a gravity based system. Be a lot easier to update and manage and control. When should you care? When your accuracy needs are smaller than about 4 meters. So I'll show a map in a moment, but your expected longitude changes will be between 2 and 4 meters across the continent US, more than 2 meters in Alaska, and more than 4 meters in Hawaii. Expected mean sea level height changes. When we say mean sea level, we're just talking about NAVD 88. Again, we're not changing the elevation of the ocean, we're just changing sort of the reference point. So it's going to be 2 to 4 meters across the United States as well. We're not sure yet about Hawaii, and more than 2 meters in Alaska. Plus, the big part of this is going to be time-dependent changes for all the control as we move forward. So this will not be a static system as we currently have. NAD 83 has not changed. I mean, currently we're in iteration NAD 83 2011, but essentially has not changed since it was issued. The numbers behind it, from NAD 83 to 1990, Cores 99, 2007, 2011, those are just readjustments. Essentially, let's add more control in there, make some statistical adjustments, and come up with some slightly, hopefully better coordinates with new measurements, but the system did not change. Again, when should I care? Here is a copy of a survey that we recently did at the University of Florida Gainesville campus, and you can see the underground utilities here. The gray is the asphalt road, and here on the west side you can see a fiber optic cable, a gas line. This line right here is a 36-inch storm RCP, reinforced concrete pipe. A couple of water lines here. Got an old terracotta 12-inch gravity sanitary line. Another water line here. 4 electric. Here's your scale right here. This is in feet, so 5 feet there. So we're looking at maybe, what, 10 feet from here to here to the center of the pipe. Of course, this pipe, again, is 36 inches wide. So we've got 1.5 feet to get over here. So this is really tight. So if this has been surveyed and then somebody came out with some coordinates and said, here, go stake say a new light pole to put it right here, and somebody didn't want to check anything and they just started drilling, we could have some serious issues. And this would be a serious issue. This was in about 2009 when somebody hit a gas line. So it's important. Really expected changes to horizontal positions across the United States. So we're looking at almost 1 meter down in South Florida, pushing past 1.5 meters up into the Pacific Northwest. When we're right here, we're referring to horizontal positions, we're referring to the latitude and longitude. Those numbers will change. Changes to orthometric height. So your numbers from NAVD 8 is going to change right here in Florida. This 0 meter change is roughly the I-4 belt running across. You can see up here we're decreasing and up here in the Pacific Northwest, we're dropping just over 3 feet. This is going to be a difficult issue for Florida. We're looking at here, Miami will be coming up about 0.2 in elevation, and up in the north end of the state, Jacksonville is going to drop about 0.4, with again the hinge point being roughly the I-4 corridor. And I'm sure people across the country have had issues between the NGVD 29 and NAVD 88 datums. You know, what datum is your information in? In Florida, it's roughly a foot across the state, not exactly all the way through, but roughly a foot. So it's easier to kind of find that. But when we're looking here at a couple of tenths down in the Everglades, where it's essentially flat, where you might have 1 inch of fall across an entire mile, it's going to be a challenge to keep up with that and manage that. Here is the look of the shifts from, these are all core stations across the United States. Roughly here, this is the horizontal change. This distance right here, this length is 2 meters. So you can see here we're looking at almost 2 meters shift across North America right there. And here is the vertical change measured in the ellipsoid height. And so we're going down almost 2 meters up here across. Again, back a little snapshot of Florida. This is a change through here. You can see down in Key West, we're quote unquote raising the elevation up 0.7. Miami 0.2. Orlando 0.03 of a foot. Tampa 1/10 of a foot. Jacksonville 0.4. Pensacola 0.7. What to do with historic charts and maps? Well, the first question is your accuracy of that data better than a few meters? If it's no, it's not even worth the trouble. Yes, you have trusted metadata with which you can pull the chart from the NRS. Again, WGS84 is not part of the NSRS. So if you don't have the metadata, you're probably not going to be able to do much. If you do, you can use NADCON and VertCon to update these datums, and they're coming up with a new tool called NCAT, N-C-A-T. It's currently right now available on NGS's website that you can start making these some calculations right now just to see how things might work. Transformation tools. NADCON will change latitude, longitude, ellipsoid heights. Currently, from what I understand, NGS has worked with the Corps of Engineers and CoreCon, which everybody's used. From what I understand, CoreCon will not be updated, and CoreCon or some of the capabilities of CoreCon are being pulled into the NGS's tool. VertCon will deal with orthometric heights. Why do we need this? Excuse me. So basically, it comes down to the ellipsoid is a mathematical model of the Earth. Basically, it's a three-dimensional oval or spheroid, sphere that's going to squash at each end. And essentially, we have some of the historic ellipsoid datums. The United States was Bessel back in 1841, Clark, which was NAD 27, GRS 80, which is the one we use for NAD 83, and then the WGS 84. Essentially, WGS 84 and GRS 80 started out the same. You will notice here out about 6 decimal places. We're going from a 2 to a 3 right here. One of the geodesists from NGS calculated what difference that would be, and roughly from Anchorage, Alaska to Key West, we're looking at about 3 millimeters difference. So essentially, these are the same mathematical shapes. But the problem is, we're looking, the center of the Earth, we're looking at about 2.2 meters total difference between the two. WGS 84 and GRS 80, which again was NAD 83, essentially started off almost in the exact same position. But over time, NAD 83 was again launched based off GRS 80. This was all started before GPS. And with new technology, with GPS going up and using stuff, we realized quickly that NAD 83 or GRS 80 was not at the center of the Earth, the center of the mass of the Earth. The military, over time, made some changes. That's why sometimes you'll see WGS 84 and then a parentheses after it with the GPS week. I think one of the first ones is WGS 84, parentheses like 532 or 534. NAD 83 has not changed. It's still in the exact same spot that was defined back in 1980. One of the reasons for this is the control across North America, and it's tied to a lot of legal system issues. Property corners, a lot of survey data is all tied to that, and so they've kept it very static. While the military has adjusted WGS 84 over time, I believe the last time they did it was early 2000s. When we go to 2022, we will be moving back to WGS 84 almost. The difference will be about 1 centimeter, so most of us don't really care. Here's an example of the Columbus, Ohio forge station. At this point, we're essentially moving the center about 1.5 meters. This is slightly different than the 2.2 meters I mentioned because we're actually doing a move and slight rotation. So there will be a slight difference between point to point. We throw around ellipsoid, geoid, orthometric heights. Here's just a quick explanation or a graph of what these are. So the ellipsoid height, again, was the mathematical shape of the Earth. The orthometric height is essentially the surface of the Earth. A geoid is a mathematical model. To get from ellipsoid, you get ellipsoid heights from GPS. GPS gives you 3 things: latitude, longitude, and ellipsoid height. So it measures from that mathematical shape, and we use a geoid to calculate the orthometric height, which is the surface of the Earth. One of the new things that 2022 will take into effect is tectonic plate velocities. Here is a picture of the Earth with some of the velocities. At the bottom, you'll see the scale of 2 centimeters a year. You can see here that North America on the left horizontally is kind of pivoting from east to west in a counterclockwise motion with the center somewhere down here near the Yucatan. And we're looking at roughly 1.5 centimeters of movement from east to west across North America. Obviously, we have some differences up here in California with the earthquakes and the tectonic plate movement, but generally for North America, we're moving from east to west. And these will be accounted for occasionally, just like WGS 84 has made some changes over time. Vertical, on the right, you will see that here's your scale. We're looking at 5 millimeters per year for this amount. Up here in Canada, we're seeing uplift because of the glaciers are melting, and we're actually measuring the ground rebounding. And we have some subsidence in primarily a lot of the United States. What can you do to get ready for 2022? You can understand the magnitude of the changing positions and heights for your clients and your community. NGS has webinars that you can go online and look for, and you can sign up for. You can actually click a link, and it'll let you know if anything new is happening. Matter of fact, there's having a webinar tomorrow on state plane coordinates. I'll show a slide for that in just a moment. NGS has new plans for the state plane coordinates. using the same parameters we've used for NAD 83. Mostly, they should be changing the false northings and eastings. So the projections will stay the same, but we would be getting essentially different northings and eastings out of it. Here's the webinar I mentioned tomorrow. Michael Dennis will be discussing again the state plane and what some of the final decisions have been made, if anything final has been made yet. They are making an attempt to reach out to the states and let the states make their own decisions. Also, there are half a dozen really good videos posted by the Geospatial group from the Florida Surveying and Mapping Society. It's on YouTube. You can search for Geospatial group. Dave Doyle is pictured here. He's retired head of NGS, and he hosts them. It's very good information. There's, again, 4 videos, one horizontal only, one dealing with vertical, one dealing with geodesy and datums right here, which is basically the 20 and 22, basically trying to pull all the others together. Also, you can reach out. NGS has advisors across the United States. Regional advisors, you can go to the website and find out who your regional advisor is, and they can help you. And if they cannot help you, they can put you in contact with the right person at NGS to answer your question. Does anybody have any questions?
Again, for anyone asking questions, we would prefer that you type your questions and then I'll relay them to Randy, just to make sure we're not stepping on each other.
One of the things to note, I kind of missed it before, but again, we were referring to handheld devices. It's very possible, not possible, it's very well expected in the next couple of years that some of the new cell phones monitoring the new GPS frequencies will be able to get an accuracy of between 10 and 50 centimeters. 10 centimeters is about 4 inches. So with that, and with plate tectonics of moving about 1.5 centimeters a year across North America, it's possible in the very near future that you could use your cell phone to actually measure plate tectonics every 6 years. You got 10 centimeters a year, divide that by 1.5 centimeters for the movement, and you could very well see the differences with your own handheld personal device.
Since I don't see any questions coming in via the chat box, I'm going to open the floor to audio. So if anybody has any questions, concerns, observations, or recommendations, please feel free to take your phone off mute and go ahead and ask Randy, or let us all know what you're thinking.
I would be more than happy to revise this presentation for a specific audience. If anybody is interested, they're more than welcome to contact me, and we can see if we can try to gear something strictly to your needs.
This is Ken Bergman at Fort Leonard Wood, working for AGC and Tech and Geospatial. This seems to be all rather sudden to me anyway. How long has this been in works? And I would definitely like to take up on your offer to brief this to the engineer school. Over.
Perfect. Thank you, Ken. This has actually started in 2007. Some of the geodesists at NGS started talking and said, you know, things are changing. We already know there's issues with NAD 83. We can see it. And so they had a geospatial summit in 2007 and came out with a report, and they started putting things together, and then there was a new report, or I'm sorry, a new summit in 2013, much more organized. They had everybody pretty much done their research, and they put together a very good architect plan or architectural type plan of moving forward, and that is the blueprint for what they're using right now. That is online. I should have had a copy of it up here, but I believe if you probably go to NGS's website, if you wanted to read it, I think it's about a 300-page document. Some of it's kind of dry, as you can imagine, but it was the Geospatial Summit of 2013.
Roger. So get in touch with you. I can send you my email address, ken.bergman@us.army.mil. But I would definitely like to get you over here to the engineer school and or Army Geospatial Center to brief folks that don't know this already. I'm sure some people do.
Ken, can you see my email on the screen?
My computer would not bring up the webinar.
Oh, what? I'm sorry about that, Ken. I got ken.bergman. What was the end at where?
Yeah, ken.bergman@us.army.mil. MIL.
Sure, Ken. I'll send you an email.
Thank you, sir.
Sure. Anyone else have any questions or comments? Well, I really appreciate everybody's time today. I thank the Geospatial Working Group for allowing me to present this. And we are going to try to work together and provide hopefully more seminar or webinar type information. I will be at JETC conference in Kansas City in May if anybody would like to come by our booth and look me up and try to talk about anything more specifically.
Randy, thank you. I want to thank you again for your time and your effort putting this presentation together for the collected group. Also want to recognize folks that we can see online. It looks like we've got folks from NAVFAC, the Army Corps of Engineers, Ken Bergman from the Army Engineer School out of Fort Leonard Wood, Hannibal Hurton from the Air Force, and a host of other folks, OpNav. Looks like we've got somebody from NOAA, and then all those that don't have their identifications here. This is what this is about. It's the cooperation between organizations and private industry. So this is exactly what this Geospatial Working Group is about, and we hope that you all join us in our future endeavors, hoping to collaborate and share this type of information about our community, our profession, to others. So they can succeed in their missions. So again, thank you all, and we'll look forward to hearing from you. And then also, our next Geospatial Working Group is in June, which will be provided by the Office of Assistant Secretary of Defense for Installations and Environment. Their DISD program, they'll talk about the installation governance over spatial data in the United States military. So once again, thank you all. Randy, thanks again, and have a great week.
Thank you.
Thank you.